A single living cell divides. Within moments, those isolated parts multiply and lock together, forming a highly organized, complex tissue. We see this behavior across every scale of reality. The mechanisms of physics, biology, and human sociology operate through vastly different materials, yet they all rely on an identical structural grammar to build systems that survive. We map this grammar through the Cosmic Trinity, a formal disclosure map detailing precisely how raw relational potential hardens into a physical, persistent world. Look at the right panel of this diagram. To understand this map, we have to establish a strict boundary. We are not claiming material reductionism. We are not attempting to compress the complexity of human society down to the mathematics of a quantum particle. Instead, by stepping away from domain-specific vocabularies, we can uncover a domain-agnostic algorithm. We gain the ability to see how any form of reality endures. This diagram outlines three bedrock principles: coherence, resonance, and cohesion. Coherence establishes the initial alignment that makes relation possible. Resonance provides the dynamic force that turns alignment into an active process. Cohesion provides the stabilization required to persist through time. To understand how pure potential becomes a structured reality, we have to trace the exact 5-step mathematical stabilization cascade that links these three pillars together. A simple 3-step metaphor fails under pressure. True systems require precise mathematical transition points to survive the chaos of reality. The cascade begins with coherence, or C. This is the baseline state, the source condition of intelligible relation. It is the raw potential for connection. But on its own, it is completely static and fragile. In fact, pure alignment is a functional dead end. Without a way to orient toward one another, elements suspended in an undifferentiated mass cannot interact. This graphic maps how a system solves that problem using the hidden mediator, phase. Denoted by phi, phase acts as a lens. It provides differentiable orientation, giving coherence the directionality to interact without fragmenting. Without phase, relations dissolve into static noise. With phase, pure potential gains the capacity to enter into an active relationship. Differentiated by phase, relations are activated by resonance. This dynamic force, rhythm, and feedback sets the system into motion. But we immediately hit a volatility problem. Resonance alone is unstable. Left unchecked, it amplifies destructive noise. We can prove why resonance must be controlled by looking at the systemic failure modes. This chart illustrates incomplete cascades. Coherence without resonance remains stagnant, aligned but lacking energy. Resonance without cohesion generates volatile noise, leading to collapse. Forcing cohesion without difference causes fusion, erasing internal identity. Mere alignment and energetic activity guarantee nothing. A structural bridge must exist to lock those dynamics into a durable form. Here is the ultimate operator, solving the volatility problem: cohesion. The equation of persistence is K equals S sub C of R. Cohesion arises when resonance stabilizes under coherence preservation. A cohesive system survives by dynamically regulating change, not by freezing in place. Cohesion is the mathematical bridge. It is the exact, measurable threshold where an abstract process hardens into a persistent, recognizable world. Once a system stabilizes, the narrative scales up. Isolated structures combine to form complex networks through the mechanics of relational boundaries. Internal cohesion holds a system's core identity together from within. When two separate systems link, they utilize adhesion, an external, boundary-crossing cohesion. Adhesion must preserve difference while connecting distinct identities, preventing fusion to enable higher-order complexity. Without this precise mathematical balance between cohesion and adhesion, reality would be a universe of isolated, static particles, rather than living, interconnected ecosystems. This recursive fractal illustrates how adhesion allows the universe to scale infinitely outward. At the microscopic level, cohesive atoms establish adhesive bonds to build cohesive molecules, forming the cohesive structure of a cell. Macroscopically, cells form adhesive networks, tissues, to construct a fully cohesive organism. Higher-order reality does not require a new set of rules. It is simply the exact same stabilization cascade running in nested, expanding rings. The Atlas matrix validates this cascade across vastly different human and scientific fields, revealing the invariant laws of manifestation. In physics, field alignment leads to oscillation, stabilizing into bound states, creating matter. In medicine, physiological integration sparks homeostasis signals, resulting in organismic resilience. Moving to human domains, we look at economics. Here, exchange potential sparks market feedback, eventually stabilizing into trust-mediated exchange. Regardless of whether the material is a quantum field or a human economy, the exact same structural syntax governs its survival. This final synthesis model outlines the absolute invariance. First, identity is nothing more than cohesion successfully preserved through transformation. Second, law is simply that same cohesion generalized across those transformations. The world persists solely because coherence aligns, resonance activates, and cohesion holds. We began with a paradox. Why does a universe of ordered structures exist rather than a universe of random volatile noise? The answer lies in the grammar of emergence. By mastering this universal sequence, we can recognize the shared structural logic governing the persistence of any system in existence.